Welcome to the Explainer. You know, the ground beneath your feet feels pretty solid, right? Well, today we're going to dig deep, literally, into our planet's structure and the incredible forces that are constantly reshaping it. And this stuff, it's absolutely essential knowledge for the general science section of the ASVAB. All right, so here's our game plan. We'll touch on why this is even on the test, dive into the Earth's layers and rocks, then look at the planet's huge jigsaw puzzle. After that, we'll talk about the super slow continental drift and finish up with a little ASVAB knowledge check. Let's get into it. Okay, section 1. What's on the test? We're talking about understanding the very ground beneath your feet. So why does this matter for the ASVAB? Well, to put it simply, this stuff is a big deal in Earth science. You're definitely going to see questions about rock types, the planet's layers, and what makes the continents move. It's all fair game. And think about it. Understanding terrain, why there are mountains here or why earthquakes happen there, that's just critical knowledge. All right, let's get to the good stuff. Earth's layers and rocks. Think of this as a journey to the center of the Earth. So let's start at the top with the crust. This is the thin, rocky shell we're all standing on. And when I say thin, I mean it. It might seem huge to us, but compared to the rest of the planet, it's like the skin on an apple. It only makes up about 1% of the Earth's total volume. Just 1%. But here's where it gets interesting. The crust isn't all the same. Nope, you've got two different kinds. There's the oceanic crust under the oceans, which is pretty thin, only about 3 to 6 miles thick, but it's made of super dense rock. Then there's the continental crust. That's what we live on. It's way thicker, like 20 to 30 miles, but it's actually less dense. And this whole density thing, it's a huge deal. It's going to be really important later when we talk about what happens when these two collide. Okay, so right below that thin crust, you hit the mantle. And this layer, it's the heavyweight champion of the planet for sure. It's this massive zone of super hot, dense rock. Now here's the wild part. Even though it's mostly solid, over millions of years, it can actually flow. Kind of like super, super thick, slow motion honey. And check this out. Just how massive is the mantle? It makes up a whopping 84% of the Earth's entire volume. 84%. That's just nuts. So basically, almost everything that makes up our planet is actually this giant, super hot layer. And finally, we get to the very heart of the planet, the core. It's like a planet within a planet, with two parts. You've got a liquid outer core made of molten iron and nickel, and then, right in the center, a solid inner core. It's so hot you'd think it would be liquid, but the pressure is so immense it's actually forced into a solid state. Crazy, right? So that crust we talked about, it's made of 3 main types of rock, and each one has a totally different backstory. First up, igneous rocks. Think ignite. These are born from fire, basically. They're formed when molten rock, like lava, cools down and gets hard. Granite is a great example. Then you have sedimentary rocks. Think sediment. These are made when tiny bits of rock and debris get deposited in layers and then squished together over millions of years. Sandstone and even coal are types of sedimentary rock. And last but not least, metamorphic rocks. These are the transformers of the rock world. They start out as one type of rock, either igneous or sedimentary, and then intense heat and pressure, well, they metamorphose them into something totally new, like marble or slate. Okay, so we've got the layers down, but how do they all fit together? Well, that leads us right into the planet's jigsaw puzzle and the huge idea of plate tectonics. You know how when you look at a world map, it kind of looks like South America and Africa could just click together? Well, for a long time, people thought that was just a coincidence, but it's not. The theory of plate tectonics is what explains it all. The big idea is that the Earth's outer shell isn't one solid piece. Instead, it's broken up into these massive jigsaw puzzle pieces we call plates, and they are constantly gliding over the mantle. Okay, to really get this, there are 2 important words you have to know. First is the lithosphere. That's the plate itself. It's made up of the crust plus the rigid top part of the mantle. Think of it as a giant solid raft. Now, what does this raft float on? That's the second word, the asthenosphere. This is a hotter, softer part of the mantle that's kind of like a thick, gooey liquid. So you've got these huge, rigid lithosphere plates just kind of floating and sliding around on the softer asthenosphere below. It's this movement that causes continental drift. All right, so these plates are moving. What happens next? Well, we get to see the result, the slow continental drift. And believe me, this is a process that's millions of years in the making.
Now, when we say slow, we mean slow. These continents are moving at about the same speed your fingernails grow, so you're not going to feel it. But over hundreds of millions of years, that adds up. And how do we know this is real? Well, one of the biggest clues was finding the exact same plant and animal fossils on the coasts of places like South America and Africa. There's just no way for them to get across an entire ocean. The only possible answer? Those continents used to be joined together.
And just to put this all in perspective, let's look at the timeline. The Earth is about 4.6 billion years old. The first big burst of complex life we have in the fossil record, the Cambrian explosion, that was only 540 million years ago. That means for billions of years before that, these forces were already at work, shifting things around. And they haven't stopped. The continents are still moving today, and 100 million years from now, the map of the world will look totally different.
Okay, we've covered a lot of ground. Now it's time for an ASVAB knowledge check to make sure it all sticks. Let's test what you've learned.
So these are the 10 big ones you really want to lock in your memory for the test. We're talking crust, mantle, core, those are the layers. Then lithosphere and asthenosphere, that's the plate and the gooey layer it floats on. And of course, the big ideas, plate tectonics and continental drift. Finally, don't forget the 3 rock types, igneous, sedimentary, and metamorphic. If you can define these 10 terms, you are going to be in fantastic shape.
Okay, let's try a real ASVB-style question. The rigid, outermost shell of a planet, comprised of the crust and the upper portion of the mantle, is known as the... Is it A, asthenosphere, B, core, C, lithosphere, or D, geosphere? Take a second, think about it. If you picked C, lithosphere, you nailed it. That's exactly right. The lithosphere is that solid outer part, the crust and the top of the mantle, all bundled together to make the plate. The asthenosphere is that soft layer underneath it. Great work if you got that one. And that wraps it up. I think the biggest thing to take away from all this is that our world was shaped by these incredible, powerful forces. The ground we stand on isn't static at all. It's on a journey that's been going for billions of years. Makes you wonder, what will our planet even look like in another 100 million years?